Hi there, Professor. I just want to demonstrate the operation of my Mechatronics final project. This takes a little while, so I'm actually going to start it up, get it running, and then I'll walk you through everything in the system. So while I'm doing this, you have to turn on the on button. It supplies the 24-volt supply with power. As you can see, the IDEC PLC HMI turned on. You need to power the DC motor speed control. And I have a safety circuit in here, so anytime the e-stop relay is off and ready to be initialized, the green button will light up. So I initialize that. Okay, if you can see on my screen, there's reset, auto run, and manual mode buttons at the top, and the bottom 5 squares are lamps, and it will designate which state the operation is in. And it will go from 1 to 5 until the very end, in which case you'd have to hit reset and the program is ready to run again. So I'm going to hit auto run. Now, as you can see, let me start with the actuator itself. As it's moving, I left the home switch. It's about to pass by a IR proximity sensor. I built that from scratch using an IR emitter detector setup. As you see, whenever the stage is in front of the sensor, the light indicates that it is. Say it was an obstruction to something in the process. It will continue to move until it reaches the target end switch. It will wait 1.5 seconds and then it will reverse until it reaches the home switch. So let me walk you through some of the components and what's going on with the system. As I said before, the on-off switch supplies a 24-volt supply with power, which then powers the IDEC HMI plus touchscreen, which supplies the Arduino and all of the other components. So, as you can see right here, this is my Arduino controller. It's used in conjunction with the IDEC. The function of the Arduino is basically to indicate what's going on in the system and give the operator indicators of where the system is at and what is happening. So as you can see, there's a ready light, there's an active light which is now lit up as it's moving. Either it's forward or back, that light will stay on. And there is an end of cycle buzzer. Also tied to the Arduino, as I said before, is the proximity sensor. So basically, the Arduino has 2 forms of inputs. One is a serial interface with the IDEC PLC. It will send serial pulses to the Arduino, in which case it tells it to turn on these 3 indicators: the ready light, the active light, and the end of cycle horn. And it uses its own internal circuit to control the IR sensor. As you can see, it hits the end switch, the horn sound, and it is at stage 5. And once you hit reset, as you can see, none of the lights are on. It is not ready to run. I hit the reset, went from 5 to 1, and the ready light is on. So I actually want to run this again and show you some other components I have built into the system. So it's ready to run. I hit auto run. Lights are working. One feature I added to the system was a safety circuit. This includes an e-stop button, a light and horn, and as well as an initialize button when the e-stop relay is on and ready to be reset. The initialize button lights up. So say at any point you want to hit an e-stop, the light goes off, the horn signals. It will keep going until you release the e-stop button, in which case all the safety requirements are met and the initialize button lights up. So I push that and the process continues. That is because I fed the 110 volt power supply to the motor through the ESR, opposed to running the entire board through it, which would kill everything. I just killed the operating controls. So another little feature, I suppose, would be in the actual control. didn't get a good shot of this before, but as you can see, it's currently in state 2. State 1 is home, it's the initial state. State 2 is active forward. It's going to hit the switch, and state 3 is a reversing pause. It waits 1.5 seconds before an active reverse state, and it will remain in that state until it reaches the home switch, in which case it will be the end of cycle. The cycle cannot be repeated until the reset button is pressed on the HMI. Also, say for some reason a switch was triggered, I felt it was necessary to put it in a manual mode. This manual mode has 3 options, either forward, reverse, or return to home. As you can see, they're all touch buttons, and they will not run when the program is being run. So, previous screen, I'm currently in state 4. As you can see, my proxy sensor LED is lit, and it is approaching home. The DC motor speed control gives me variable speed on the motor. That's about it. Alright, reset, and she's ready to run.